Good morning, ladies and gentlemen. Today we are going to talk about transformation of functions. Um, Before we get started, I'm sorry this is coming out on Saturday and not on Friday as planned. I was really sick all day yesterday and I'm still recovering, if you cannot tell from my voice. So our objective is to be able to transform a parent function in the form g of x equals a times f of c times x plus h plus k around a graph based on the equation without using a t-table. Now, this all seems very technical at first, but we will break this down throughout this lecture. Um, so let's get started. So first off, we have vertical shifts. Now, a vertical shift is just what it sounds like. It is a shift up or down a graph. And I have f of x here, and I use f of x throughout this entire lecture, but f of x is just the parent function of whatever it is. It could be square root of x, oops, x, it could be x squared, it could be x cubed, but f of x is this primary piece right here. Um, Absolute value of x, whatever. All right. So what happens when we add a number to the end of these outside of the actual operator, it's going to do a shift of one direction or another. Now, if it's f of x plus k, we shift up k units. Plus k up. Negative to k down. So let's see how this looks like on the function of a quadratic. So if we look at our quadratic here, we have f of x. Now, if we were to change this d value, or sorry, our k value to say 2, let's see what happens. We shift up 2. As I go up more, you can see this is what we're adding on, and this is where we move. So I can keep changing these values to play with them. As I add up to 3, I go up to 3. If I subtract 1, I go down 1, down 2, and down 3. So all this does is shift your graph up and down by adding or subtracting outside of the function. All right, so going on, here is another example of it. F of x plus 4 will shift your graph up 4, 1, 2, 3, 4. F of x minus 4 shifts your graph down 4. All right, so now let's talk about horizontal shifts. Let me make sure. Yep, this is where I'm at. All right, horizontal shifts. So this is a shift to the left or right, horizontally. So for everything h is greater than 0, you'll notice I have two different forms as well. I have y equals f of x minus h, and this is y equals f of x plus h. Now let's first look at the difference between a horizontal shift and a vertical shift. So I have a, let's say, a horizontal shift, and this is a vertical shift. Now for horizontal shift, and let's say our function is square root of x. Now for vertical shift, we learned that it was outside of the square root function, right? I have square root of x, and then I'll have plus 2 to shift me up to. Now, if I have a horizontal shift, I'll have the square root of x minus 2. Now, to see the difference, the minus 2 is under the square root, so therefore it is being applied horizontally. It is being applied directly to x. X is on our what? Horizontal axis. Therefore, anything applied directly to x, adding or subtracting, will shift you left or right. In this case, it would shift us to the right 2 units. Given by our rules here. So f of x minus h, if you're subtracting, you go right. It is the opposite of what you think. If you're adding, you're going left h units. And here is the basic example of this. If I have f of x here and I subtract 4 units, I go 4 units to the right. F of x plus 4 units, I actually go 4 units to the left. And we can see that again on this. If I take my c value and I shift it, here's minus 2. And again, you could watch the numbers up here as the graph shifts here. I'm adding, oops, wrong one. Shift it right. If I add, I shift it left. Subtract, shift right. Add, shift left. All right, so now let's talk about some vertical stretching, shrinking, and reflection. So our shrinking, stretching, and reflection comes from the form y equals a times f of x. So we have y equals a times f of x. And that will give you a vertical stretch or a shrink. So if I have my f of x values, so my outputs are 1, 2, 3, 4, and then my transformation is 2 times f of x. Well, we can see how if my original output here is 1, but I multiply it by 2, I get 2. 2 times my original output of 2 would give me 4. 2 times my original output of 6 or 3 will give me 6, and 2 times 4 will give me 8. So that's the stretch, and we'll see that in a second. Now the shrink is if it's a fraction. Now obviously, if I come and I have 1/2 f of x, and my numbers are still the original f of x, so now if I have 1, if I plug 1 in, I actually get 1 over 1 times 1/2, which is 1/2. If I plug a 2 in, I get 2 times 1/2, which is 1. So it actually shrinks all your original y values by half, right? And then the reflection part as well, if anything is negative out in front, if your a is negative, well then it's going to reflect. And let's look how all this works together now. So now I'm looking at my a value. A is right here. We can see if it goes up as a increases in number, my graph gets what? Narrower. If I go to 2, originally on my red parabola, I'm at the point 1, 1. Well, guess where I'm at now for my blue one? 1, 2, because I've grown by a factor of 2. If I was at 2 here while I was at 4, well, I'm going to be all the way up where? At 8. You can't see it, but it's up there at 8. And you can check that with any of these points in between. So as I grow, my graph gets narrower and narrower. Now let's see what happens when I turn into a fraction. Now we go into fraction decimals greater than 0. The smaller my decimal is, the wider my graph gets. Now we can keep going until I get to 0. Now obviously if it's 0, then my whole function is y equals 0. And then as soon as it turns negative, you see what starts to happen? And I go to -1. Now -1, it's just negative f of x, which you could see I'm at 1, 1 here. Well, on my reflection, I'm at 1, -1. All my points just get turned to negative. And if I were to keep going, I can see at -2, or about -2, my graph gets skinny again. And it starts going to keep getting skinnier, narrower, and narrower until I just keep going up and up. So that's my stretch and my reflection. You can change the values, and you can see how your graph changes. Now, our last topic for this lecture will be horizontal stretching, shrinking, and reflection. So this time, we're doing it horizontally, not vertically. Now, a lot of you are going to say, oh, this looks quite the same. And it is, and there are some ways to tell just by this how it's going to look as opposed to your a f of x. Sorry, that didn't make a whole lot of sense, did it? Just erase that from your memory. Let's move on. So first, let's talk about our function here. We have y equals f of c times x, where c is greater than 1. This shrinks the graph y equals f of x horizontally by a factor of c. So now instead of shrinking it vertically or stretching it, we get a shrink. And now this time, since it's horizontally, things seem to be a little opposite than our verticalness, right? So in order to get a stretch here, our c value has to be a fraction. Remember, here to get a shrink, we had to have a as a fraction. Here to get a stretch, our c is a fraction. So we can see there is a slight opposite going on there. And our reflection is still the same. It is c is less than 0. And so let's see how this looks like on a graph. If I have c and I change, oops, this is the wrong c. They use a different notation on here. Put this back to default. All right, so now if I look at this, get over where you belong. Thank you. All right, if I look at this, as this gets bigger, as this number is greater than 1, I still get my shrink. But then as it turns into a fraction, it goes wider again. It's a stretch. Now, don't get the horizontal stretching confused with a vertical shrink. There is a slight difference because of the variable you are manipulating. And then once we get negative, we can't really tell the difference, right? It just, because everything's being squared, it is already symmetrical about the y-axis. So that's why you don't see the reflection. However, if we were to look at something else, like let's say a cubic graph, and now let's this go negative, what happens? Oh, now we could see what happens when we're negative, right? Now we can see the reflection about the y-axis. But most of our, there we go. That's what happens when you change that value. And so I believe that brings us to the end of transformations. If you need more work, there will be another video posted later this evening with additional work that you can follow along and do with me. Thank you and have a good day.